Hi everyone and welcome to my channel. Today I'm gonna make an ideal MCM5 version which will be with high current 2 parallel battery. The guys who are watching my channel quite a long time, they know that I do have already an 1000 watt-hour version of MCM5. I built it and I've used it for 2 years, and now I came to the conclusion that the previous version of my MCM5 build is not the ideal one because the difference of weight just in batteries between high current 2 parallel version and regular 4 parallel version of battery is more than 1 kilogram, and that's just a rough weight of the batteries without any extra things like the welding belt, like the heat shrink tape, like the extra wires and all the stuff which is required in battery builds for that purpose. And since I'm using this wheel mostly for commuting purposes, I usually take it into tube with me and into the offices, and I have to go upstairs sometimes, and more than 1 kilogram of extra weight is a really significant issue for me, and I would like to make this wheel as light as possible. So now I am including the screenshots of app which calculates different parameters of the batteries, and you can see that the difference in weight and the performance is really significant between the high current version and the normal version of the batteries. Also, I want to make an announcement that EUCU now has the anti-spark cable for the new models of Begode, which includes 3 wires connection system to the controller board with MR60 connectors. So it might be useful if you do have a master or T4 or M10-4 wheels, and if you did some maintenance to your wheel by yourself, it is really important to connect your controller board for the first start with such device to avoid any burnouts if you missed something or made something wrong. This little thing may save you lots of money, so if you do have such a wheel, feel free to contact and order one from EUCU Instagram. Traditionally, I will leave the link to EUCU Instagram in the description to this video. Here I do have a black controller board, and of course I plan to install here a custom firmware from Freestyler. So in this video I'm going to cover up this flashing process and how to install this custom firmware and to make some configurations if necessary. So now I'm going to disassemble this wheel, prepare it for all year usage, prepare it for all road, weather or winter conditions, and of course I will show you some interesting moments, and after that I will build a custom battery and of course show you how it is connected and how is everything installed inside this wheel. So stay tuned, let's go ahead and do that. So here I showed you how it's easy to remove the motor from the inner shell. There is no need to separate the inner shell halves, or for example to drill here an extra way for the motor cable. The trick is that you can just pull up a little bit these inner shells. Since it's not the metal but the plastic, it's really soft, and what you have to take care about is this motor cable, not to damage it by these sharp holes of the inner shell when you pull the motor out and pull it back. So it's only one thing you have to take care about, and the time for tire maintenance significantly improves. So I have disassembled the motor and was really upset by the quality of the assembly of this motor. I consider this motor absolutely defect and it shouldn't be ever sent to the customer, but by the ancient Chinese tradition, the manufacturer doesn't give a fuck about quality and sends it as is to the end user. So let me do a real quick review of the defects I found in this motor, particularly in this stator. So the first defect was that the motor wire insulation was damaged. Luckily, there was damaged only the outer side of it. The inner wires were not damaged, so I have made a reinforcement of the insulation here, put here a lot of heat shrinkable tape. Right on this spring, also used a lot of sealant here to reinforce this part of the wire coming out from the shaft as much as possible and to prevent any problems which might be caused by this damage in future. The next awful thing in this stator is winding. You can see that it is done really inaccurately. For example, in this place or here you can see that this part of the winding is really moving, like this one as well. But the worst part of this winding is really here. By the damage in this part, I can judge that there was some kind of strike here and one of the wires was really damaged. And what the manufacturer did, they just soldered this wire, put the heat shrink tape on it and left it like this. But if we take a closer look at this part of the winding, we can see that it is moving with really big angle, and it is really obvious that during rides there will be lots of vibrations, movements of this part of the winding, and this soldered wire will be definitely touching the motor cover while it's rotating, and the friction between this wire and the cover will eventually destroy it, and as a result there might be short circuit in this motor and the rider will fall down from the wheel. Of course, it's not safe to leave this stator like this, and right now I'm going to take a small rope to fix all these parts of winding very well. Then I put here a lot of lacquer so it will act like a glue and the protection for this stator, and only after that I will assemble this motor back, and by doing so I will be really sure that nothing will happen in future use of this motor. So I have assembled this motor, I fixed the windings very well, and now I am ready to tell you about one interesting moment I promised you at the beginning of this video. So you can see here the spacer rings, which are stock ones. Those two, they are from two different motors. Right now I am working on two wheels, and so I have two motors disassembled here. And you can see by your own eyes that they have really different thickness. So if we make some measurements, we can see that one is 3.3 millimeters. I hope you can see that very well right now. And the other one is 4.4. Maybe you see it. Okay, so that thickness is really different. Here I do have a spacer plate. I've already measured the thickness of the original stock ones. It's 2.5 millimeters in both motors, and I've measured it previously. This size never changes, it's always 2.5, but the size of the spacer rings really changes from wheel to wheel. Sometimes it might be 3.3, sometimes it might be 4.4, or it might be 4.8 or something. So nobody at the assembly line of the motor doesn't care about the dimensions of these spacers. And of course it is really obvious that when you assemble the wheel, when you tighten the inner shell to the pedal hangers, sometimes they are tightened not so properly, and this might be the cause of cracks of the inner shell. So it is a crucial point to have the same dimensions of the spacer rings for all wheels to make the inner shell alignment to the pedal hangers as best as possible. The second reason I've started to talk about these spacer rings is that in the previous video about MCM5 I showed you guys the way how to install these standard sealers. The dimension of the sealers is 22 by 32 by 5. So that means that the thickness of this sealer is 5 millimeters, and it is not possible to install it with these 3 millimeter or 4 millimeter spacer rings. You have to modify a little bit these sealers to remove a part of it and to remove the inner lip as well, which is not really the best way to install the sealers. And my friend, his nickname will be in the description to this video, invented a new way how to install these sealers without modifying them. Like to install them in stock one, not to sacrifice this inner lip, and to make the protection of the bearing as much as possible. So what has been done to reach that goal? So the stock spacer plate has been milled, 0.5 millimeters has been removed from its thickness. So right now it's only 2 millimeters thick. That was done for 2 spacer plates left and right for each wheel. Also, there have been made custom spacer rings with the thickness of 5.1 millimeters. This spacer ring allows to install this sealer without any modifications, so it installs there really well, nicely and tightly, and there is still a space between spacer plate and the outer lip of this sealer. Right now you can see I have already installed the sealer with the custom ring, and everything is fine. So right now I'm going to assemble this motor with these custom details and install it into the wheel well of the inner shell. So I have prepared the inner shell for assembly. I did a great reinforcement of the pedal hangers area, so now this part of the wheel will be really reliable. I've also covered a useless hole for a useless music speaker by the plastic. Originally it was covered by this shitty foam material. So now this part is very reliable and no water ingress will be possible from here. I've melted thread bushings inside this part of the inner shell, so this is the place where my BMS will be fixed. It will be fixed like this. This is the back cover of the BMS I've used as a template for drilling holes for these thread bushings. And now, as I finished working with the inner shell, it's time to talk about the electrical part of the wheel. So first of all, this is the front panel of the wheel, the electrical panel, which I've modified a little bit. So this is the stock light. I've left it as it was before. Here I have removed a useless USB charge port. I've replaced it with the custom power button with the backlight, so this button will now turn on and turn off the wheel. Also, I've modified the charge port. I've united each 2 contacts for plus and for minus. By doing so, I make sure that when I would like to charge my wheel with 10 amps, for example, there will be no extra heat of these contacts and everything will be fine. Originally, from the factory, it is done like it is used only 2 contacts of 4. So you see here there are 4 contacts and only 2 are used in stock variant. And of course I've left the stock power button, which will be no longer the power button but will be the wake up button for my BMS. And here comes the problem I'd like to talk about. So this is the BMS, this is the latter version of ANT BMS. It is 20S version, and this version doesn't come with the power button like the former one. And there are only 2 ways to activate this BMS. By the way, what is activation? What does it mean? When you connect this BMS, you firstly boot it, set up, and then you can work with that. But after some time, it falls asleep. This is done for battery saving purposes, and if you want to connect to this BMS once again and get any data or information about your battery, you have to wake up it, and this may be done only by 2 ways. First way requires a power flow through this BMS. which means that you have to charge or discharge your battery. And the second way is to apply a voltage of 3 or 5 volts to this connector. So you may see here I have already soldered a stock connector which comes with this BMS. So when you apply this voltage, typically in the user manual it says take just one cell and connect to these wires, and you've done, and that's it. But the question is where to get this 3 or 5 volts when your wheel is turned off and it is not working. To solve this riddle, I began to look very attentively to the BMS and find out that there are contact points here near the balancing wires connector. I don't know why they were made, maybe for debug purposes. When you connect your BMS, check everything is fine, and you can just put here your multimeter tips and check what is the voltage. So each of the balancing wires has this small pad, and we have here B minus and B plus. And the plan is to solder wires here to B minus and B plus. By doing so, I will have the voltage of just one cell of my battery, which will be equal 3 or 4.2 volts, which is okay for waking up this BMS. And then I will connect these soldered wires through the stock power button to this standard connector, which comes with BMS. And by doing so, I will be able to wake up my BMS using this button anytime I need. For example, when it is resting in the stand, turned off, and I need to check, for example, whether I need to charge my battery for the future ride or not. Or, for example, during the ride, I want to know what is the temperature, what is the status of my battery, and so on and so forth, because I do not plan to connect the controller board through this BMS for safety purposes. And this is really useful and necessary information to take care of your battery and to make its life as long as possible. So right now I'm going to solder that, assemble that, and show you guys how it is all connected. I have assembled the battery cells into the holders. Now the battery assembly has such kind of shape. It looks like this. Here is the one temperature sensor. Here is the other one. They are fixed on the batteries using the thermal transfer compound, and one may ask, why didn't you put the thermal sensor right in the core of this battery? The reason I did this, if you take a closer look here, you can see that the space between the cells is pretty small, and if you take a look at this thermal sensor, they are too big to get inside. So in this particular version of BMS, it is not possible to put temperature sensors right inside of the battery core. And from my point of view, those places where I fixed those battery sensors are the best for the whole battery assembly monitoring, assuming that they are not installed into the battery core. I'm always using such kind of holders for all my DIY battery projects, because the whole battery assembly is not just looking really nice and has proper shape, but also it adds lots of safety to the battery assembly, because now the whole assembly is really rigid and all cells are very well fixed. All cells have space here between each other. You can see here in this labyrinth that there is enough space not to touch each other, and you know that the EUC is a highly vibrating device, and vibration can cause friction between those cells, and as the result there can be possible short circuit, and this kind of assembly eliminates this. That's the main purpose of using holders. Another great feature of these holders is that they already have these labyrinth traces for the nickel belt strips. You can just cut needed length and simply weld it here in this labyrinth, so you do not have to think about how to weld it, how not to short circuit your battery and not to get any problems. This is very simple and allows you to weld the battery as fast as possible. The author of these battery holders is Evgeny. I will leave the link to his Telegram nickname in the description to this video, so you can contact him if you need such kind of battery holders to be printed. As you may have already noticed, I am going to use the cells Molicel P42A, which are really powerful cells. Just one cell can give up to 45 amps of constant current, By the way, the config of this battery is 20S2P. And now I'd like to talk a little bit about where to buy such kind of batteries. I don't know how in your country, guys, but in Russia we do have a problem buying original cells, because there are a lot of scam sellers, and you can buy just repacked elements which may be non-original. I personally had such a problem when I tried to buy Samsung 40T cells for my RS high current version. The video about it is already on my channel, you can check it out. So I've ordered 40T, and when I received that, the truth was that it wasn't original 40T cells. It was repacked elements, so I had to send them back to get my money back and reorder molybdenum cells. And I had to wait quite a lot of time. And the problem was that while waiting for these cells changing, I've lost my summer season. So I had assembled my RS only in the late fall, and it was pretty cold already. And I couldn't ride it because, you know, when it's really cold outside, you can't go 60+ kilometers per hour. So right now my RS is waiting for a new summer season. And it was pretty sad story to lose the whole summer just because of scam sellers. Speaking about these cells, I've bought them from Queen Battery Store on AliExpress. I will leave the link to this shop in the description to this video. If you need such kind of cells, feel free to order them from there. This is not my first order. I've already ordered these cells several times from Queen Battery shop. I've checked them many times, and all the cells are in parameters of datasheets for molybdenum P42A in terms of internal resistor and capacity. So I can judge that these are original cells, and you can order from Queen Battery without any problems, and not bothering that you will get some scam cells instead of original. If you guys know where you can buy original cells at your site, please feel free to share in comments. Again, I don't know anything about your story, but in Russia it's a really big problem where to buy original cells and not to get some kind of shitty elements. So right now I'm going to weld this battery, to solder the power wires, BMS wires and balancing wires, and show you guys how it will look like inside the wheel. the assembly of this wheel I also did another two mods. First of all, I have removed a stock LED strip and I have installed a custom one. It is located in the rear part of the inner shell. It is bright, steady red light, which will help me to be visible on the road. And as the second mod, I have installed a custom display, which I really like on this wheel. So now it is time to take a look how the battery is located, how everything is connected. So the battery is located in this compartment. I must say that it fits here really tightly, and there is no possibility to add more cells in this compartment, but this particular battery fits here very well. This side of the battery has all the balancing wires which are coming to BMS here. On this side we have the power line and the charge line, and also there is a thermal sensor cables you can see right here. So on the BMS connector side, this connector goes directly to the former power button of the wheel. Right now it works as a wake up button for my BMS. On this side there is another connector as well, which is located under these balancing wires connectors, which I soldered to the contact points of the first battery cell. And I've already tested this button, it works very well. So if you are building your custom projects with this type of BMS, please keep in mind that you can take this solution and use it for you. So the temperature sensor connector is here. You see the wires are connected here as well. Here is the Schottky diode, which is connected through the XT30 connector to the charge wires of the battery pack. During the assembly, I've been thinking a lot where to locate this Schottky diode, and I've got an interesting idea to locate it right on the heatsink of the BMS. So that's what I've done. And one may say that this diode at high currents can heat up this BMS very well. And yes, I agree with that, but I do not see any problems with that since I have connected my controller board bypassing the BMS. The maximum current flow through this BMS might be 10 amps. This BMS can hold up to 80 amps, so that's 8 times less than nominal current of this BMS. And I don't think that the power MOSFETs located in this area of the BMS will heat up significantly during the charge process. Also, we have here the area where the balancing resistors are grouped, and they also heat up this heatsink through the thermal pad. But according to the settings, the balancing will start when the charging current will drop less than 1 amp, and this is really not a problem. And with that current flow, the Schottky diode will not heat up this heatsink with any significant value. During the assembly, I've covered the BMS from both sides with the special compound to make the hydro protection and to make sure that everything will be reliable here if I will ride during the heavy rains or weather like that. And as for the power line, these are the wires. They go directly to the other side of the wheel where the controller board is, so it is bypasses the BMS, so there is no risk that if the BMS will catch some bug or something, there will be no cutout due to this problem. So the wheel is being pre-assembled, and now it is time to flash a custom firmware from Freestyler, and I'm going to show you how to do this process. For that purpose, you're gonna need an Android device. In this case, we do have a smartphone, but I think the tablet PC will work as well. Originally, to flash a custom firmware, you had to set up a custom proxy server in your system. It was not so comfortable, not so easy, because you had to search for new proxies since the old ones were expired. And now EUC World app can flash custom firmware without any problems, and it has a really user-friendly and easy interface. And right now I'm going to show you how to use it. So now the app is connected to the wheel, and we have to go to settings, then to the wheel settings, then we have to go to firmware, and here we have to check the firmware channel. We have here two options. First option is the official stock firmwares. This is basically the same that is available in the Begode app, which also can flash you official firmwares from Begode. And the second option is custom firmwares modified by Freestyler. This is what we really need here, and of course we make sure that we check this option to continue. After selection of needed firmware channel, you have to go to firmware update, Right now we can see only one firmware, which is MCM5 PWM tilt back. This is exactly what I need to flash in my wheel. Also, we do have here a warning that those firmwares are not original and what you are doing is all at your own risk, but I do not care about that, and this is what exactly I need, so I will accept that. So I select this firmware and click update. And while the app is doing its job, I'm going to tell you about this firmware, why do you have to flash it. So I've been riding with this firmware for about a week and I'm really satisfied with that, because right now with that firmware the wheel has the option of the PWM tilt back. So as soon as your wheel reaches the dangerous level of PWM, it starts to tilt back the pedals, and if you are riding in the night with your front light turned on, it starts flashing with it. And with that features enabled, the wheel clearly tells you that you are reaching the dangerous levels of your PWM and you have to stop pushing your wheel harder, otherwise you will get the cutout. This is a really cool safety feature, and frankly speaking, sometimes I'm too lazy to start my wheel lock on my cell phone to get alerts by speed or PWM. Because I do not really need them anymore, since my wheel can do the same very clearly, and it's much more reliable because you do not have any Bluetooth connection between your cell phone and the wheel, and of course you do not have any lags and things like that, and your cell phone, for example, will not hang up and so on and so forth. So getting hardware alerts from your controller board is a really cool feature. I don't know why Begode didn't do that in stock firmwares, but right now, thanks to Freestyler, we do have a custom ones, and I really recommend to flash this custom firmware for everyone who bought a new Begode wheel with the black controller board and use it in daily life, because this adds a lot more safety to our wheels. So now the flashing process has been finished, the wheel has been turned off by itself. This is pretty normal. I'm going to turn it back on and I will use the wheel lock for further configuration, just because I prefer it and I use it in daily life. And if we go here to settings, then wheel settings, then alarm mode, and we can see that now we have additional setting here, custom FV PWM tilt back. We check that to apply those settings, and after that the wheel will do the pedal tilt back and strobe the front light if it's turned on, as soon as it will reach the dangerous levels of PWM. Finally, I finished my work with this wheel, and now it's time to make some conclusions about the work was done. Now this wheel has become a true performance wheel, because right now on the market there is no available and such powerful wheel in 14-inch class. Because Begode removed 800 Wh version of MCM5 from the market, and right now what you can buy is a weak 400 Wh two parallel low current battery pack version of the wheel, which is absolutely unacceptable for enthusiast riders who prefers Begode and Godway wheels. And the only way to get a wheel like this is to buy that weak MCM5 and to modify battery pack to get either 1000 Wh or 600 Wh to parallel high current battery pack version, like I did in this particular wheel. I also would like to ask you to give your appreciation in the comments to this video for the author of the custom firmware, Mr. Freestyler. I'm pretty sure that he will definitely like reading appreciation comments from you guys, and this will definitely inspire him to make new, better custom firmware versions for our wheels in future. So that's about it. If you like this type of tuning, leave a like, comment this video, subscribe to the channel, and see you later, guys.